Okay, we're going to go ahead and get started. So this will be up later, obviously, if you're watching it later. But this is just a quick overview of everything that will be on this exam that I'm going to be able to expect, that I'm going to be expecting you to be able to explain. All right. So, and this isn't in any order. It's just kind of the stuff that I found first. Okay. But this is mostly everything. All right. So a big piece of this is asymptotes. All right. I'm not going to bother going through all this right now. But everything you would need to know about asymptotes, at least for the time being, is right here. Okay. So if you want to pause and write that down, I would recommend having that in front of you as you're explaining those problems. But that's all there for you. Okay. End behavior, that's all this stuff. Okay. This is split up a little bit strange, but this is when the degree is odd. This is when the degree is even. And then leading coefficient is positive. Leading coefficient is negative, positive, negative. And it's all there. I'm not expecting you to be able to describe the behavior in terms of this. All you really need to do is draw something that looks like this. Okay. And we'll cross that bridge when we get there on the example problems. Okay. Intermediate value theorem only really comes up when you're beginning to graph things on this test. All right. And essentially what it means is between vertical asymptotes, all the values are going to be the same. So if it's above a horizontal or slant asymptote, then all those values will be. If it's below, then all those values will be. And then the two other things that we need to know have to do with rationalizing and the vertex form. So the vertex form is on the bottom left. That's y is equal to a times x minus h squared plus k. And the vertex in each of those cases is hk, right? So we take the opposite of what's inside, and then we take exactly what's outside. And then rationalizing, the big thing to know here, there's like three major things. That's what I is actually equal to. So the square root of negative 1, that's always going to be equal to I. I squared is always going to be equal to, and this should be negative 1. Okay. In order to rationalize something with the square root in the denominator, you need to multiply by the denominator over itself, unless that thing becomes a sum or a difference, in which case you have to multiply by the conjugate of the denominator. Okay. All of that we're going to go over, but this is a very quick snapshot of everything that I'll be able to, that I'm going to be expecting you to be able to explain. Okay. So if you need any of this, if you want to screen cap it, if you want to write it down, it's there for you. Okay. So that's that. I'll give that a couple of seconds. But what we're going to do next is we're going to go over every individual type. Okay. So I actually took one of the tests that I was going to give, and we're just going to go through each of those step by step. All right. And then if you have questions after, I'll take those, but I want you to be able to see each individual question before you actually dive into it one more time. All right. So with that, let's go and go for it. All right. So again, this was actually going to be a test that I was going to give you. All right. But I just pulled it out of the rotation. And then we're going to do it now. All right. So the first question on everyone's test will be convert the following into vertex form, then label the vertex, show all work. All right. This show all work here is important. Please be sure to do that, especially when you're explaining it. Okay, because I'm going to be grading you based off your explanation of this stuff. All right, and in order to do this, in order to convert this quadratic into vertex form, we need to make it look like y is equal to a times x minus h squared plus k. All right, so to do that, right now all we're worried about is this stuff right here. So all we're worried about is the a squared plus 6a. So we take the coefficient of just a, and we divide it by 2. Then we take this value that we just got, and we square it. So we get 9, okay? This is the value that we have to add inside that red box. All right, so when we do that, we get a squared plus 6a plus 9. All right, and that's our red box. And then on the outside of that, we still have minus 14 equals negative 7. And because we added 9 on the left, right, we added this 9, we also have to add 9 on the right. All right, and the rest is just factoring and simplifying. Okay, so after we get all of this, then we factor that red box. And when we do that, we need factors of 9 that add up to 6. In that case, it's just 3. Okay, this minus 14 is equal to positive 2. Then we have to get everything to the left, and then we're pretty much done. So we get a plus 3 squared minus 16. And then this is our equation in vertex form. Okay, so this is the first part. That is this part of the directions. But we still have to do the second part. Okay, but this part should be easy. It doesn't really require any math. All right, we just have to pull out the opposite of this guy and then this guy. All right, so our vertex is hk, so it's negative 3, negative 16. And then that's full points. Okay, so just running through this one more time. We take our middle value, we divide by 2, we square it. We add that value to everything basically in that red box. And because we add it on the left, we have to add it on the right. All right, then we factor. Whoops, that's not what I wanted. Then we factor. Stop it. We factor, we simplify, and then we pull out the vertex. Okay, so that is question number 1. All right, moving on to number 2. Label the degree and leading coefficient, and then describe the end behavior of each function. Again, so 2 different parts to this. There's label the degree and leading coefficient, and then describe the end behavior. All right, so the first part should be really easy. All right, the degree is just the highest exponent in each of these. So the degree in number 2 is just 3. This is odd. The degree in number 4 or number 3 is 4, which is even. Then the leading coefficients. Leading coefficient of the first is just 1, right? There's nothing attached to the x cubed, so it's just 1. That is positive. And then the same thing for number 3. Okay, so that's part 1. And then part 2 is to graph it. or at least get a good shape of the graph. Right, so the end behavior of number 2, right, the degree is odd. So it's going to start down low and end up top. Number 3, it's even, so it's going to start up top and end up top. Okay, so this will do for your end behavior. Okay, moving on to number 4. This is when problems start to get maybe just a little bit bigger. There's a couple of sets of directions here, right? So graph the following, like that is our ultimate goal, but we have to use end behavior, intermediate value theorem, and the zeros in order to do that. Okay, so what I would recommend is to get the degree and leading coefficient first. Right, so the degree here is 3. That is odd. The leading coefficient is 2, which is positive. And then that tells us the end behavior, right? So that tells us that it starts down low and ends up top. Okay, then we should find the zeros. And I'm only going to give you something that you're able to factor. Okay, so our goal would be to factor this entire function. So we want to factor 2x cubed minus 8x squared minus 42x. And between each of these terms, right, there's a 2 and an x in common in each of those, right? We can pull a 2x out of 2x cubed, we can pull a 2x out of 8x squared, and a 2x out of 42x. So when we do that, we're left with x squared minus 4x minus 21. So then we're almost done, right? We can still factor this part. So when we factor that part, we need factors of negative 21 that add up to negative 4. So that would be x minus 7, x plus 3. And then it's all factored, but we still need to set it equal to 0 because that's what we're trying to find. So 2x equals 0, x minus 7 is equal to 0, or x plus 3 is equal to 0. So x equals 0, x equals positive 7, or x equals negative 3. Okay, so then we can start to graph, right? So we find the degree and leading coefficient, tells us what that means about end behavior, then we find the zeros. And then we're able to graph it. Right, so we found our zeros, we found 0. We found positive 7. And we found negative 3. Okay, so we know what happens on the outer edges, just from our end behavior, right? So it's odd and positive, which means it starts down low. And it ends up top. Okay, now our job is to figure out what happens in here and over here. So we have to plug in values into our original function. Okay, so let's plug in something over here. All right, so we can plug in -1. And when we do that, we get some positive value. All right, so we get positive 32. Okay, that will be above, right? That's above that x-axis. So all the values must be above it. And really would be a lot sharper to come way up top. Okay, but then we have to plug in something over here. So let's plug in 1. And when we do that, we get some negative number, right? We get -50. So it has to be below the x-axis, okay? And that is our entire problem, right? So we find the degree leading coefficient. That tells us what happens on the far left and the far right. Then we find the zeros. That tells us where our graph hits the x-axis. And then we find out what happens in between those zeros. And that's that stuff in purple. Okay, if it's above the x-axis, then it's always going to be above the x-axis between those two zeros. Right? If it's below the x-axis between those two zeros, then it's always going to be. Okay, so that's number 4. All right, and then we can move on to number 3. Okay, so divide by using long division, show all work. All right, so in order to set this up, do 4n plus 4 into 36n cubed plus 28n squared minus 16n minus 9. All right, so our goal is to figure out how many times 4n goes into each of those terms, then we multiply it by everything. Okay, so 4n goes into 36n cubed 9n squared times, right? 9n squared times 4n gives us 36n cubed. All right, so then we multiply this by both of these two things. And when we do that, we get 36n cubed plus 36n squared. And then we're subtracting that, just like we would normally do in long division. Okay, and when we subtract, we are left with -8n squared. Then we have to bring down this value and rinse and repeat. Okay, so we need to find out how many times 4n goes into -8n squared. And that goes into -8n squared -2n times. And then we multiply that by both of these. So -2n times -4n, that's -8n squared. -2n times +4 is -8n. Subtract, and we are left with -8n, right? -16n minus a -8n, right? So that makes it positive. So we have -8n. Then we bring down this value for the last time. And again, do the same thing, right? So 4n goes into -8n, -2 times. Multiply that -2 by each of these. And then subtract. -9 minus a -8, that's just -1. And that's our remainder. Okay, so our total answer then is 9n squared minus 2n minus 2, and then minus 1 over 4n plus 4. And that's our remainder. All right, so that's number 5. Number 6 is kind of in the similar topic. All right, we're doing the same thing, but we're going to use synthetic division. In order to start this, we take m minus 9, this guy right here, set it equal to 0. We get 9, right? And then we set up our box. So we put 9 on the outside, and then each of these coefficients inside the box. So 1, negative 19, 100, and negative 90. All right, we drag down the first value and then multiply this value by this value. And that goes right up here. Add down. So we get negative 10 and then rinse and repeat. So negative 10 times 9 gives us negative 90. Add down. We're left with 10. And then back up to give us positive 90. Add down, and we get 0. Okay, so this is our remainder, and each of these are coefficients of m with degrees 1 less than what you see up here. Okay, so our total answer, right, is m squared minus 10m plus 10. Right, so this is all the correct work, but if you don't have the final answer, then there will be points off. Okay, and then the next part is rationalizing and dealing with imaginaries. There's only going to be 2 of these, right? One maybe a little bit simpler, and then one a little bit harder, having to do with multiplying by a conjugate. Okay, but we'll get there. So let's do number 7 first, right? Whenever we have just a square root in the denominator, so nothing else, we just multiply by that square root over itself. Right, we're just multiplying by 1, so we're not changing anything. We just have to cancel out that square root. All right, so when we do that, we get negative square root of 34 minus 3 rad 340. Right, so we multiply this top by the negative 1 and this. Then on the bottom, we have 34. And that's it. We're done. Right? You probably can simplify that a little bit more, but this is the part I'm worried about. Okay. On the right, on number 8, whenever you have a sum of 2 things, whether that be an imaginary number or a square root, we want to multiply by the conjugate. So we need to multiply by the conjugate of the denominator, which is negative 10 minus I. And we have to do that in the top and the bottom. Okay, when we do that, we get negative 20 minus 2i up top. And then if we FOIL the bottom, we get 100 minus I squared. Right? So that's the difference of squares. So I'm using a shortcut. If you want to simplify, or if you want to FOIL it, that's fine. You just got to make sure you actually do FOIL it. All right, so when we simplify this a little bit, we get negative 20 minus 2i over 100, and then I squared is always going to be negative 1, so we have minus a negative 1, so it's negative 20 minus 2i over 101. And that's our answer. All right, so that's number 7 and 8. Again, that has to do with rationalizing and imaginary numbers. And then we get to the last problem. Okay, and the last problem is a little bit tricky because there's a lot of different things that can happen. But really, what we're trying to do is we are trying to follow these rules. All right, and then maybe a little bit of intermediate value theorem, but mostly just these rules. All right, so I would have these out in front of you when you are doing these. All right, so Let's go back down. All right. Whenever you're doing these, the first thing I recommend is getting the vertical asymptote. And first, let's go over the directions, right? It says identify each asymptote, vertical, horizontal, or slant. And then sketch the graph. Okay. And then it has all the point values for what they're worth. All right. So we need to find vertical. We need to find horizontal. If there is no horizontal, we need to find the slant. That's most of the points right there. Actually, that's half the points. And then we need to graph it. So to find the vertical first, that's kind of the easiest. We set the denominator equal to 0 and solve. All right. I can factor this. All right. Factors of -6 that add up to -1, -3, and 2. So x minus 3 is equal to 0, or x plus 2 is equal to 0. So x is equal to 3 or -2. Right, so those are vertical asymptotes. So we plot those. All right, then we find the horizontal. All right, and the horizontal has to do with comparing the degree of the numerator with the degree of the denominator. Right, so the degree of the numerator is 0. The degree of the denominator is 2. Right, so in this case we have n is less than m. So we go up to our rules. And we find n is less than m. So y is equal to 0 is our horizontal asymptote. So we plot that. That's just the x-axis. All right, and then we've done step 1. Okay, then we need a graph. Okay, in order to graph, we need to test values in here, and over here. All right, so let's start with the left. All right, so let's plug in f of -3. So when we do that, we get a positive denominator, but because this negative outside, we get a negative number. So we get -1 over just 6. All right, so we have -1/6. -1/6 is always going to be below our horizontal asymptote. So our graph is going to look like this. Then we need to test the middle. So we test f of 0, right, 0 right here. So we plug that in, we get -1 over 0 squared minus 0 minus 6. So that's -1 over -6, which is a positive number. Okay, 1/6 is going to be above our horizontal asymptote, so our graph is going to look like this. Okay, then the last one, we can plug in something to the right. So let's plug in 4. So we get negative 1, 6 again. That's always going to be below our horizontal asymptote. So our graph is going to look like this, right? So we find the vertical, we find the horizontal, and then we test it in between each one, right? And so that would be full points, that would be full explanation, and then that would be it, all right? So that is the entire thing. Yeah, you're only going to have to do one asymptote one. And I will say on the test, you will either have 2 vertical asymptotes or a slant and 1 vertical asymptote. All right, so just be aware of that. You will be having to use all the rules. Okay, so that's the entire like test. Okay, so I'm gonna leave this open for a couple minutes and take any questions that you have. If there are no questions after about 5 minutes, so like 9:15, we'll call it there. This will be available afterwards. Okay, so in I think like 30 minutes or so, this will be uploaded and available to watch. And in fact, guys who are on here right now, you can pause, rewind anyway. I think it just takes a couple of minutes for it to be actually like visible. All right, so ask me any questions you have, and I will do my best to answer them. Also, you can always email me or Teams me or whatever. So if you do have questions after this, you can do that as well. In the meantime, I'll slowly scroll through this, all right, just so you can see it if you weren't here before. Um, yeah. All right, so since there are no other questions, I'll end this here. If you do have questions further on, again, like I said, please email me, use Teams. I can help you out. All right. I will email this test out at about noon today, and then this will be due at 10 p.m. the day of your final. All right. Please, please finish that final before you actually walk into the exam room. All right. I highly, highly recommend it. All right. So I'll leave this open for the next 30 seconds or so, and then I will end the stream.